Yo, 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 what is good, everybody? Guys, we made it. We made it to day 3. Let's write this up top here. This is day 3 of our final exam study guide for MathWorks. All right, so we're here. We are here. We're here. We're here. So we've made it to this part, and we're now going to go ahead and get to the last portion of it. So last two sets of videos, we actually did questions 1 through 10 for day 1, and then day 2 was 11 through 20. So now we're going to do 21 through 30 today, and that's the end of the study guide. So let's start with 21 here. All right, so 21 is talking about vectors. And so we have vector A, we have vector B, and we're going to add those two vectors together. So they want to know what is the sum of vector A and vector B. So all we're going to do is we're going to write down what vector A is, what vector B is. And if you remember back in our notes, we talked about vectors having a different symbol too. They could have parentheses, they can have the little brackets that look like this. You can have that too. Those are all vectors. So this will still work too. So depending on what book you look at, you will have it on there. So cool, we're good. All right, so all we're going to do is add them up. So I'm going to do it visually because most people are visual. A lot of people are visual. So all we're going to do is we're going to add them up. It's like a regular equation, huh? All right, so 7 plus a negative 2 is a positive 5. And then 3 plus 6 is 9. So we have 9 and 5. Cool. That's it, guys. That's all we had to do. If you wanted to write in vector form, another vector form, you can actually do those little bar thingies too. It's up to you. Don't really matter because, yeah. Either way means vectors, as long as you have the symbol there. All right, so number 22. This time it says to subtract them. Subtract them. So here we have two different ones. So we have that vector A minus vector B. All right, so with it, make sure we first off remember to distribute this negative to both terms inside the second vector. So technically we're dealing with addition again. It's a negative 8 and a negative 7. All right. Again, I'm going to put it over here to the side. Add them up, add them up, add them up, add them up, add them up. We're not going to line them up. We're going to add them up, add them up, add them up, add them up. Oh, fire! All right. So we get that. So 4 and negative 7 is negative 3. 12 and negative 8 is positive 4. So 4 and negative 3. So we get those. Bam! Easy, Mr. Hall. This is easy. We got this. We know what we're doing. Vectors, remember, we're easy. Vectors and matrices pretty much are the same type of stuff that we're doing. Easy, simple, not hard. All right, 23. Now, for this course, we did not actually focus on solving exponential equations because it's really not part of this course. That's what you did in Math 3. So for this course, I'm still giving you this problem because you can still figure out how to do this if you know your rules of exponents. And if you go back to your notes when it came to the log equations, log functions, I think it was example 2 where we talked about how to solve out the equations and we had a variable inside of it and everything. One of the things we said, we got to a certain point and we said, okay, well, it was exponential, looks similar to this. We said, okay, they didn't have the same base, so how are we going to work it out to be able to figure it out? We said, hey, if the base numbers, we can get them to be the same thing, we can set our our exponents equal to each other. Well, in this case, our exponents are equal to each other. The two functions are equal to each other. So if that's happening, that means the bases should be equal to each other also. So the exponents equal each other and the whole thing equal to each other. That means the bases have to equal each other also. That makes sense. So we're going to do 4x plus 1 equals 13. We're going to go ahead and solve this out. So subtract 1 from both sides. Gives us 4x equals 12. And then we divide by 4. And we get that x equals 3. Woo! We got 3 there. Uh-oh, we got this. And if you're just wanting to like check it out just to make sure you got the right answer there, we can do that real quick too. So I'm going to go back to the original equation that we have right here. We're going to put 3 in for x. Y'all cannot see that. Let me pull that in really quick. We have this part here. So we said x is 3. And you'd be like, oh, Mr. Hall, I can see it already. It works out. It's right. I'm like, let's go ahead and let's get this first. Let's do it. Let's actually do the work. Let's show the work. So 12. So 4 and 3 is 12. Plus 1 is 13. And like we said already, like you guys were saying, Mr. Hall, we can see it. It works out. You're absolutely right. It does work out. Bam. Yeah. We got x equals 3. Bam. So that gets that answer there. If the base numbers are equal to each other, the exponents are equal to each other. The exponents are equal to each other, then this should work out. All right, so that's what we did. That's the what we did. That's the what we did. That's what we did. That's the what we did. No eating fish tonight. We're on a diet. All right, so I had to put a bunch of stuff together. Sorry. All right, so 24. 24. We're moving along. We're chugging along. Chug a lug. If you're a Cosby Show fan, if y'all know what that's all about. You probably don't know. Y'all too young for that one. All right, so looking at our next one, I'm just writing down the problem for number 24. All right, so again, just like we just talked about on 23, 24 works very similar too. All right, so we're talking about things that are equal to each other. If these equal to, then these should equal and all the great stuff. So if you look at it, okay, we have a log here, a log here. Okay, yeah, those are the same. We have a 7 back here for this x value or this x number or in the x spot. So if that's the same, and if that's the same, doesn't that mean that this should be the same too? Or at least, if not the same, they're equal to each other. Because everything else is equal, so why can't that be equal too to match up? Because if one side equals another side, everything should equal each other, right? Right, Mr. Hall, you got that. All right, so let's do 18 equals 2x. All right, so if those are the same, we can solve this out, divide by 2 on both sides. We get x equals 9. If you want to put that in the calculator, you can put that in the calculator too. We don't have to, but if you want to put that in the calculator, you can do that too, just to put it here. But if you look at it too, 9 times 2, 2 times 9 is 18. 18 is 18. Everything else is the exact same. You're right. You know you're right. You got it. So you don't even have to go back and check it and put in the calculator or anything. You can see it right there. All right, cool. All right, let's do one more in this video, and then we'll do the last ones on the last video. All right, so that's 24. So let's do 25 real quick. Oh, let's do 25 and 26. Let's do those two. All right, so this one is dealing with our log equation itself, a simple equation, and we need to solve for x. Right? So if you remember back when we did this before, we talked about a thing called swoosh. This is what I call it. It's not really called swoosh. That's what I call it. I think about SpongeBob and I'm like, bring it around town, Pepe the swoosh. That type of stuff right there. So with that, I'm rewriting it, just moving the 2 in front. So that way we can go back to what we talked about. So it goes here, here, and then here. So we brought it around town. Swoosh. Bring it around town. So that's 6 squared equals 3x. All right. Easy, Miss Hall. We got this. We know what to do next. All right, so we got 36 right here because that's what you know you need to do next. Equals 3x. Then we divide by 3. Mr. Hall, we got this. We know what we're doing. We're going to pass this final exam. Yes, ma'am. Yes, sir. We got this. We get x equals 12. All right. So if you want to go back and check it, you can just put 12 right there, and that'd be 36. And then yeah, we can actually say it, or just put it there, and then we get 36 equals 36. We good, guys. We're good. So that is number 25. We get an answer of 12. All right, and then 26 is the last one we're going to do in this video. All right, and this one is asking for our transformations. All right, so on top here, before we actually go into the work and everything, and actually let me put it below it. Remember before, we've had all this great stuff going on. This pink is really weird to me. I'm sorry, guys. I don't know if it's showing up pink on you guys' side or red, but this is pink and it's weird. It's very weird. Oh, sorry, that should be a C back here, not a 5. Ha! Should be a C. This is the letter C. This is the letter C. Letter C. I'm gonna make it a C. A letter C. All right, so cool. Now we said with C, this goes up and down. If it's positive, it goes up. If it's negative, it goes down. For B, we go left to right. If it's positive, it goes left. If it's negative, it goes right. The A, remember, it went opposite of what you thought. So opposite of what we normally say, not opposite of what you thought, but what we normally say. So if it was A was greater than 1, it actually expands. If it's A is greater between 0 and 1, it shrinks here. And then this one, the negative, means it flips about the x-axis. All right. So with that, the only transformations that we have for this problem. Very well. I used this one. All right. So what only transformations we have is this part here and this part here. There are no parentheses right here in the green problem, so there's no moving left or right. There's no number in front of the log, so there's no A. So we just go and work on this part real quick. All right, so we just say it flips about the x-axis, because we're talking about the transformations again. And it moves, and say positive. Yeah, if it's positive here, sorry. Positive means it's going up. So we say it moves up 5. Bam. All right, so our last video, we're going to put the other ones in there of 27, 28, and 29, and 30. And then we're good, guys. We're done.